Hi guys, so today we'll be solving this problem called find first and last position of element in sorted order. Let's read it. Given an array of integer nums sorted in ascending order, find the starting and ending position of a given target value. If the target is not found in the array, return -1 -1. Could you write an algorithm with O of log n runtime complexity? So in this array 5, 7, 7, 8, 8, 10, the target is 8. The first occurrence of 8 is at 0, 1, 2, 3, comma 4, and the last occurrence is at 4. So first is at 3 and last is 4. So that's what we have to return, the first and the last occurrence of a element in the sorted order. So first we can solve this problem by, you know, uh, just by looping through uh, and checking uh, if the if we find that target, we put it in the first occurrence of that target into the 2D into the matrix that we'll be returning, uh, call it answer. So the first time when we find the number, we put it in the answer vector, and then we go ahead, and when we find the second occurrence, or maybe we want to find the last occurrence, right? So when we go ahead, we mark the last occurrence into the array, into the answer array, and then we return the answer array. So this will give us the complexity O of n, but we have to optimize it to O of log n. So when we see O of log n, so we understand that binary search would be used, because binary search happens to have time complexity of log n, and in this array is also sorted. So we understand that we need to use binary search somewhere. So the algorithm for binary search would be very simple, that we'd be doing binary search twice. First time we find the first occurrence, and the second time the binary search would be for the last occurrence. So I'll code along and I'll explain how we will be working through. So let's start. So first, let me just create the vector result where I'll be storing the answer. I'll initialize to uh, -1, and let me just write the base conditions. If nums dot size is equal to 0, then we return the result. All right. So we know that if the array is empty, we return the result of um, -1 -1. Then let me just write the two pointers that we need for doing the binary search. Let's write n also. All right. Now let's write the binaries first binary search for first occurrence of the target. Okay. Now first we'll check if while I is less than j. So we create a middle element as we do in all the binary search algorithms. I plus j by 2. Now we check if nums of mid is less than the target. So we do I is equal to mid plus 1. Okay. So if nums of mid is less than the target, so we increase the left pointer to I is equal to mid plus 1. That is, we check in the right side of mid plus 1. And otherwise, we do j is equal to mid. We bring the last pointer to the middle element, and we check which is the first occurrence between I and j of that target. Maybe it might be j, or maybe it might be between I and j. So we need to check for that. So this will give us the first occurrence. Then we need to check if nums of I is not equal to the target. So we know that we haven't found the element uh, in the array which we've been given. So we return the result as -1 -1, else we do result of 0 is equal to I. So we have found the first index or first occurrence of that element, which is at I. Now we do j is equal to n minus 1. That is, we initialize the last pointer that we had at middle. We initialize it to the ending of the array, so that now you will be finding second occurrence, second binary search for the second occurrence of the target. So here, as I initialize the last pointer, the second pointer, which is the right pointer, to the end of the matrix, end of the array, so that we traverse from the middle element where we found the first occurrence to the last, so that we understand where is the last occurrence of that particular element. So similarly, while I is less than j, int middle is equal to I plus j by 2. Now I'll be adding 1 plus 1 so that it is more right biased, and we'll check if nums of mid is greater than target. So we do j is equal to mid minus 1, that we bring it to the left, else I is equal to mid. Now that completes the second second function, which will give us the second occurrence of the target. Now we'll simply store the result of 1 as j, because I assume that j will give us the second occurrence of that particular element, and simply we return result here. Now let's dry run to see how our code is working. Let me take an example here, 5 7 8 10. So let me just write it over here. So let's see how the first binary search is working. So initialize it to j. Okay, now I plus j by 2 is middle, so I plus j, it is, let me just write the index as well. So this would be 0 1 2 3 4 and 5. So 0 plus 5 by 2, that is 2 2s are 4, and since it's 5, so we take the lowest element, which is 2. So mid will be here, which is at, let me just type m here. So m will be at 7, and we'll check if nums of mid is less than target. Yes, it is. So we increase the I as mid plus 1. So I comes here, and we check, we are at 3 and 5, right? So we check if 3 plus 5, okay, wait, okay, did I do any mistakes? Okay, 0 plus 5 is 2.5. Oh, okay, so I is here, j is here, mid would come as 3, and then we need to check if we need to check if nums of mid is less than target. No, it is equal to target, so therefore we make the j come to the mid, so j comes here. Then we check in between 0 and 3, so mid of 0 and 3 would be 1, and we see that nums of mid is less than target, therefore we increase the mid, so mid would come here, and therefore we increase the mid by 1, so I comes here. Now we see the middle of 2 and 3, which will increase the pointer here, and j will also be here, so both of them will be at 3, and at that time we break out of the loop and we go to the if condition. Therefore we find the nums of I is equal to target, and therefore we put the result of I as 3, and then we come to I less than j. Then we come to the second binary search, which is very similar to what we did here. So I is at 3, then j is initialized to nums.size minus 1, and here we'll be finding the middle, and middle would come as 8 here, and we see that nums of mid is greater than target. No, it is less, it is equal to target, therefore I would be becoming equal to the mid. All right, and then we'll be checking 4 plus 5 9, 9 by 2, which is 4 plus 1 5, and nums of mid is greater than target, therefore j would be mid minus 1, which will make the condition false. I is not less than j, therefore result of 1 would be equal to j, which is at 8, and we'll be returning the answer. So let's run the code. Okay, let me just put it in comment. All right, that works. Yeah, that is accepted. So I hope you guys understood the problem. Do solve it. It's a simple one, and we try to optimize it to best time complexity that we could have done. So do solve it. Thank you.